Hello, and in this video we're going to be looking at graphs of linear functions. We're going to start off with three different types of graphing that we're going to be able to do here. It depends on what type. We're going to try all three here, but some of these will work better for you than others, so you can use whatever you would like here to graph, but I'm going to show you the three different options. Those being plotting points. Second method is using slope and y-intercept, and 3 is using transformations of the graph of y equals x. I have 3 examples here. We're going to do all 3 a different way. So we're going to start off with the first one. We're going to be plotting points. So f of x, we would need some points to do that. So we would make a chart, an f of x chart here, or xy chart. We pick some x values. We look at our graph. Our graph looks like it goes from -10 to +10, so we just need to put some values in here that is appropriate. Now, since we have a fraction here, I'm going to use multiples of 3 because when we take a third of something, I want to be getting a whole number. So I'm going to pick values that are going to give me multiples of 3. So maybe -6, that's a multiple of 3. -3, 0, 3, and 6. So I'm going to use all of those values because those are multiples of 3. And then when I take a third of it, we'll be able to figure out a whole number. So if we take a third of this, we're going to get 2. And since we have 2 negative signs, that's going to be +2. Added to 2, that's going to be 4. Okay, this one, we take a third of 3, that's going to be 1. We have 2 negatives, so that's +1. So we add 2 to that, we get 3. This one, 0, is going to drop out, so we get 2. And it looks like it's following a pattern, so the next one probably is going to be 1, and I'm guessing 0 here for 6. So let's try those out. So if I put 3 in there, that's going to be 1, but it's -1, plus 2 is 1, that's correct, and 6, a third of 6 is 2, but it's -2, so 2 and -2 is 0, so that works. So we would then go over to our graph, and then we plot these values on the graph. So plotting points is making up a chart. So we go to -6, 4, we plot the point, -3, 3, plot the point, -3, 3, it's right here. Okay, graph's a little small. So 1, 2, 3, 1, 2, 3. Okay, right there. 0, 2, 1, 2, 3, 1, 1, 2, 3, 1, and 6, 0. Okay, so then we would put a point, or we would draw a line through that. So the line would look like this if we drew it through there. It's a line, so we would have arrows on the end. Okay, so that would be using the plotting points method. We have to make a chart, plot points, draw the line through the points. Alright, in the next method we would use the slope and the y-intercept. So when we look at the equation, we're going to use this g of x function. We're going to find the slope. Here's our slope, and here's the y-intercept. Okay, so the y-intercept is -5, so that means we would start by graphing the y-intercept first. So using the slope and the intercept, we're going to do this slope here. On this one, slope, remember slope is rise over run, and we know that that is 4, so we're going to write that as a fraction of 4 over 1. We know the y-intercept is -5. We're going to write that as a point, 0, -5. Okay, and then we're going to start here, and we're going to use the slope to find the other points. So on the graph, we're going to start at 0, -5, which is right here. We are then now going to count slope as rise over run. So we're going to go up 4. We end up at -1. Go over 1. Put a point. Up 4. So that would be at 3. Over 1. That would be a point. And we can continue doing that and getting points for the graph. We can also go the opposite, which would be going down 4 and left 1, because that would be -4 over -1. So if we go down, that's -4, left is -1, so that's still 4 for slope. So we're still going to draw our line through it. Let's draw the line through these points. Okay, and then we would then add arrows to our line. Okay, so that's how we would use the slope and the y-intercept. We find that from the equation. We start at the y-intercept and plot the slope as a ratio. All right, now the final one is using transformations. So what it means is that we're going to start with this basic line y equals x. So we're going to do h of x here using transformations. So that one would be, we're going to use this graph. So we have to start off with a line. So the first line that we would start off with is compressing it by a factor of 2/3. So our general line here that we're going to use, y equals x, is going to be, let's put that in black. That's going to be 1, 1, 2, 2, 3, 3. So it's going to be at 45 degrees here from this line. So it goes through 5, 5, 10, 10. It does that. Okay. Let me extend that line. It also goes backwards. So we're going to extend it to go through the other points and the other side. So being very cooperative. Okay. All right. So this is our line y equals x. You can see that it goes through 0, 0, 5, 5, -5, -5. So they're the same values. Okay, so what we're going to do is use a transformation. So in h of x, this transformation is a compression of 2/3. So instead of going over 1 up 1, it would go over 2 up 3. So we would compress this down, so that would make it over 2 up, or I'm sorry, rise. So the compression is 2/3, so it would be 2/3 of 1. So that would be over, let's make this a little bigger. Okay, so there we are, a little easier to see. So we would move over, it'd be 2/3. So instead of 1, 1, we go to 2/3. Instead of, so at 3 it would be 2. 3, 2. It's 2/3 of what it is. At 6 it would be 4. Okay, so the line would go in this way, it would be transformed and go through those points there. Okay. And it would do that in this fashion over here, back through this point 0, 0. It's transformed through 0, 0 in the same way. Okay, so that's the first transformation, is 2/3. So instead of going up 1, 1, it would go up 2/3 of the way. So basically you go over 3 and up 2, 2/3 of the slope. Okay, and then we would have to then move this up 1. So we would take this transformation and shift this. This is telling us to go up 1 unit from where we are. This is saying we'd transform 2/3 slope of what we had before. Okay, so then we would take this function and just shift it up 1 unit. So this blue graph would then change. Let's make it a little bit like this color, the next lighter blue. So we would shift this up 1 unit to here, and it would go the same way. Whoops, we're not drawing a line. Okay, so it would just come up 1 unit, so it would be parallel to the line that we have. It would be 1 unit higher. It would go through 1 instead, so it would be this line right there. So that's using transformations. First we shift the slope, then we shift up or down depending on whether that's the positive or negative value. Okay, so those are the 3 methods. Moving on, they also talk about x and y intercepts. X and y intercepts are where they cross the x-axis and where they cross the y-axis. The y-intercept is also known as the vertical intercept. So we need to know that that's a vertical intercept. And the x-intercept is the horizontal intercept. Now we find the intercepts by taking the equation, and for the y-intercept we have it right here. If it's written in the function form, this is the y-intercept. So that's 0b, or 0, 1 in this case. Now the x-intercept is found using the function and setting it equal to 0. So the x-intercept is used by going 0, that's the function, equals negative 5x plus 1, and solving that. Well, we move the 1 over and divide by negative 5, so we get 1/5 positive because there's 2 negatives. So that's our x-intercept in this function, 1/5, 0. Alright, so that's how we would find the x and y intercepts, or the vertical intercept, which is this one, and the horizontal intercept, which is that one. So they may use a different terminology. Okay, the next part of this section we're going to cover is writing equations using transformations. So up here we graph them using transformations. Now we're going to write an equation. So it gives us the compression, which is basically, this is the slope of the problem. So the function is transforms f of x equals x by compression of 3/4 and shifts left 2 and down 3. So this one's going to be a little bit more of a shifting than we just did in the graph. We just shifted it 1 up. In this case, we're going to have 2 different shifts. So that means that we're going to have to look at finding the point, which the y-intercept using this shift. Okay. Okay, so that means when we shift left 2 and down 3, that means we've started at 0, 0, and we've moved left 2, that's going to be negative 2, and down 3 would be negative 3. So we're going to go through that point. So we know the slope, so we have this function that says 3/4 x plus b. We then know this shift, so we have values of x and f of x to put into this function to find out what b is. So we know that f of x is negative 3 at this point. We also know that x is negative 2 at that point. We would then find the y-intercept so that we can write the equation of the function. So in this case we have negative 3 equals, this will reduce by a factor of 2. So this is negative 1 and this is 2. So our answer is going to be negative 3 over 2 on that one. That's negative 1.5. We're going to add that to both sides. So we're going to have negative 3 plus 3/2 here for b. Well, that's 6/2. So our b answer is going to be negative 3/2. Alright, so that means that the equation here that's been transformed, let's write a different function here. Let's use h of x. Our transformed function h of x is 3/4 x minus 3/2. That's our answer to this transformation. That's the function that transforms this many units left and down and compresses by 3/4. Alright, moving on to the next topic here. You're going to need to know how to write equations of horizontal and vertical lines. Horizontal lines are f of x equals the number, b, the y-intercept, and the vertical lines are x equals the x values on the graph. So in this case, let's look at the horizontal line first. So here is our b value. B is 0, 4. Okay, so b is 4. So that means this graph here is going to be y equals 4, or f of x equals 4. Well, we can use function notation for that. Now, on the vertical line, we need to know what x values are on this line. So I'll just look at the x-intercept. The x-intercept is negative 2, 0. If we look at another point up here, this is negative 2, 6. Okay, so any point we look on this line where the x value is going to be negative 2. So this equation is going to be x equals negative 2. Now this is not a function, so we can't write it f of x equals. It doesn't pass the vertical line test. It is a vertical line. Okay. So you're going to need to know how to write the horizontal line equation and the vertical line equation. They're pretty basic. There's one number involved. Alright, the next topic in this section is on parallel lines and perpendicular lines. You need to know that parallel lines have the same slope and different y-intercepts. So if we were to have two functions and we said that they were parallel, then they would have the same x number here, the same slope, like 3 and 3. But they would have different y-intercepts because they would want to be different lines. If you had the same on both, you'd have the same line. You wouldn't have parallel lines. Okay, so same slope, different y-intercepts. Okay, perpendicular lines have slopes that have opposite signs and reciprocal in value. So that means that these numbers, so if I wanted to write an equation that's perpendicular to these two, let's say h of x here in this case, and I want to write it perpendicular, what we're going to have to do is take an opposite sign, so it's going to be negative, and the reciprocal. So the reciprocal of 3 is 1/3. And then we can have any y-intercept we want. The y-intercept could be the same as up here. We could have it as a +1 here. It would be perpendicular to this line and that line just because of this slope. All right, my first example here is going to be checking to see if they're parallel or perpendicular. So we have two lines and we want to check to see if they're parallel and perpendicular. Well, all we have to do is use the slope equation to do that. So we're just going to use this equation to find out the slopes of these two lines, and we're going to see if they're the same, if they're opposite and reciprocals, or they might not do either one of those things. It might be that they are not parallel and not perpendicular. There's a lot of lines that are not either one of those. Okay, so let's do line 1 first. Line 1, we're going to take a look at line 1, and it is -1 minus 5 over 5 minus 2. That's going to be -6 over 3, which is -2. Line 2 is going to be -5 minus 7 over 3 minus -3. So that's going to be -12 divided by +6. So that's also going to be -2. So these are parallel because they're the same value. Same. If I got +2, then they would be neither, because the one's positive, one's negative. If I got 1/2 on this one, then they would be perpendicular, because 1/2 is the opposite, it's a positive, and the reciprocal of 2. Okay. All right, the second example here is writing a line perpendicular. Okay, so what we want to do there is we're still going to write, so we're writing an equation of a line. So an equation of a line is we're going to write f of x equals mx plus b. So that's our equation. So what we're going to do is we're going to find the slope first, because it's perpendicular. Perpendicular meaning that here's our slope of the line, but we need to be perpendicular of that. So the perpendicular slope is the opposite sign, which is negative, and the reciprocal of 3, which is 1/3. So we have a slope of -1/3. We know the equation goes through 3, 1, so we're going to plug that point in. So f of x equals -1/3 x plus b. We're going to take, just like the problem up above where we had a point, we're going to plug this point in. So 1 goes here for f of x, because that's the value of f of x when x is 3. 1/3 times 3 plus b. So that's going to give us -1 here. So 1 equals -1 plus b. So b is 2. So our equation is going to be f of x equals -1/3 x plus 2. So we found the slope, then we plug the point into a generic equation with that slope to find the intercept. Okay, our last thing here, our last problem we're going to work on in this section is on finding intersecting lines. So to find the point where they intersect, we just take the two functions, whatever they are, and set them equal. So in this case, we're finding the points where this and this intersect. Now they are going to intersect because they have different slopes. If they had the same slopes, they would never intersect, and you would just say that they don't intersect if you see that they have the same slopes. But in this case, they do not. So they're going to intersect. So we're going to take f of x, which is 2x plus 5, and we're going to set it equal to g of x, which is negative 3x minus 5. And we're going to solve that. So I'm going to add 3x to both sides. So that's going to be 5x plus 5. This is going to go away, and you're going to have negative 5 there. So we added 3x to both sides. Okay, and then I'm going to subtract 5 from both sides. So I'm going to have 5x equals negative 10. We divide and get negative 2. Now that just gives us one value. We have to find a point. So that is telling me my point is negative 2 comma something. So I need to plug that back in. Now if they intersect there, that means I can use either equation. So I can use f of negative 2, or I could do f or g of negative 2. They should give me the same answer. So when I plug it in, negative 2 times 2 is negative 4 plus 5 is 1. If I put it in here, negative 2 times negative 3 is 6. 6 minus 5 is 1. So both of them give us the same value. So our answer is negative 2 comma 1 for the point.